In this example, we're going to be finding a couple of projections, specifically orthogonal projections. So we are going to take a couple of vectors in R4. We'll define the vector v to be the vector 1, 0, -1, 2, and define the vector w to be 2, -1, 3, 2. What we're going to do is find the projection of v onto w and find the projection of w onto v using the dot product as our inner product. So first thing we'll need is a couple of formulas. Now the way that I try to remember these projection formulas is by doing the following. Now for the projection of v onto w, I know that the final result has to be in the direction of w. So it'll be a fraction times w. V will show up exactly one time. The rest of the time, it's going to be all w. So if we're going in the direction of w, w is the real star of the show here. Now to evaluate these dot products, first thing we'll do is multiply the corresponding components of v and w together. So for the first components, that'll be 1 times 2. For the second components, 0 times -1. For the third components, that'll be -1 times 3. And for the fourth components, that will be 2 times 2. Taking the dot product of w with w, we'll simply square all of the components and add them together. So 2 squared, -1 squared, 3 squared, and 2 squared. And that'll be times the vector w. I would have actually put the components in, but we're getting really close to the edge of the page. Simplifying my numerator, I'm seeing 2 plus 0 minus 3 plus 4. That's going to be a total of 3. 2 minus 3 is -1 plus 4, yep. This denominator here, I'm seeing 10 for these two and 8 for these two, so that'll be 18 times the vector w. Now we'll actually put in the components of w, 2, -1, 3, 2. We can simplify the 3 over 18 to be 1 over 6, and then distribute the 1/6 through to each of these components, reducing as we go. First component would be 2 over 6. 2 over 6 reduces down to 1/3. -1 over 6 will be -1/6. 3 over 6 will reduce down to 1/2. And 2 over 6 we reduce down to 1/3. So again, this is the component of vector v that points in the direction of w, also known as the orthogonal projection of v onto w. Now to flip things around, if we're looking for the projection of w onto v, we're going in the direction of v, so I know that v is going to be the last thing I write up here, w will be the first thing I write up here, and everything else is going to be v. v, 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 v. Now for this we can give ourselves a little bit of a shortcut because the numerator is w.v, and we already know what v.w is from our previous problem, so that's just going to be 3 once all is simplified. Dot product of v with v, we'll just take all of the components of v, we'll square them and add them together. So 1 squared plus 0 squared plus -1 squared plus 2 squared. And that'll be multiplied by the vector v. Simplifying what we have here, numerator is still 3, denominator becomes 1 plus 0 plus 1 plus 4, that'll be 6. So 6 times the vector 1, 0, -1, 2. Just like we did for the last one, we can reduce. 3 over 6 will reduce down to 1 over 2, and we'll distribute the 1/2 through to all of these components. That'll be 1/2, 0, -1/2, and 1 once everything has been distributed through. That'll be our final answer.